Hello, welcome to Waka Breaking It Down. This is the AP Statistics Free Response question from 2010B, number six. Uh, Number sixes seem scary sometimes, and like normally you get extra time. You get like 25 minutes, well, always. Like 25 minutes is kind of what you should kind of allot for yourself. It is wrapped in with the one through fives. So, if you spend less time on this, you can spend more time on something else or whatever. But don't let them scare you too much, although you need to always be ready for some kind of little curveball usually. Half of it will usually be straightforward, and the other half you'll have to do some reasoning and some thinking out, right? Using the skills you have. Just do your best. I mean, hopefully get it all right, but even if you can get half of it right, then that's something, right? It can go a long way towards getting you a good grade. Anyway, so what do we got here? Hopefully you've tried the problem already, and then you're watching the video for the solution. So we have some house prices based on their square feet, but we also have some information about the pool, whether it has a pool or not, and they gave us the residuals from a linear model. All right, so I know when you first look at this, you're like, oh my gosh, I got to start plugging in all these values into my calculator. You do not. So don't start doing that yet until you actually read, something that tells you should be doing this, which you don't have to. So don't do it and waste your time. Okay, so they have it plotted out for you, and I can tell already, like we're going to be splitting the domain and talking about the difference between these two groups. I can see already that the circle is a little higher than the squares, so we're going to have some differences going on there, but they're very similar, right? There's my residual plot. You can see the same thing in that. And then we have the regression line for everything together in the computer output. So part A, just like my golf score, don't worry about the overall golf score. Don't worry about what you're going to get in the end. Just worry about what's in front of you. Just hit the ball, right? So one by one step, one swing at a time. Okay, so A, interpret the slope of the least squares regression line. Well, we can do that. That's nothing tricky. All right, so here's the slope, 0.165. If I need to remind myself, I can go back up here and say, what are we talking about? We're talking about size in square feet and the price in thousands of dollars. So 0.165. So the model predicts for an increase of 1 square foot in the size of the house. On average, the price is predicted to increase by 0.165 thousands of dollars. So if it's thousands of dollars, you can move the decimal 3 places, right? 1, 2, 3. And instead of saying 0.165 thousands, you could just say $165. Okay, so on average, the price of the house will increase by that much for each increase. Let me show you the answer key. So the slope is there for each additional square foot of size. That whole point of increasing by 1 is important. Okay, and then the model predicts, or the predicted, right, price of the house increase is $165. Okay, part B. Let's see what that has. So the second house on the table has a residual of 49. Interpret that value. So they just want to know that you can interpret what a residual is. Okay, so it's up here in the chart, but it's no big deal. You don't even need to know any of this other information. You just say, if something has a residual of 49, that means, let me actually go back to the chart. If it has a residual of 49, it's, maybe this one or something. I don't know. Maybe it's this one of those, right? The idea is that your actual data point is above your regression model. So the model is under predicting at that particular house value, right? So the residual value of 49 indicates that the actual price is $49,000. So I got to make sure we add that in. It's tricky. Higher than the model predicts. Okay, so nothing tricky yet. Although I just said tricky, but I meant in a different way. Okay, now here we go. The real estate agent is interested in investigating the effect of having a swimming pool on the price of the house. So, now we're going to start splitting these up, right? Pool or no pool. And I can see that down here too. I got two different regression lines and stuff going on. But we haven't got there yet, just part C. So use the residuals from all the 25 houses to estimate how much greater the price for a house with a swimming pool would be on average than the price for without a swimming pool. Okay, so all you're doing is going to the chart, looking at all the houses that have swimming pools, all these residuals, and you're going to do the average of those. So yeah, there's a little typing here. You got to add all those numbers up and then divide by 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? And get an average residual. Make sure you remember it's in thousands of dollars. And then you have to take all the residuals for all the houses that have no swimming pool, right? You take all of those, add those all up, right? And divide by how many there is. I think there's 17 of those. So you're going to get a difference. Let's look at the answers right away. So you can see they're doing that. They're taking the average of both of those sets. They get 18.6 thousand for the swimming pool and negative 8.8 thousand for the no swimming pool. So what does this suggest? Well, obviously there's a difference. The houses with swimming pools are over the prediction line more often, on average about 18.6 thousand. The houses with no swimming pool are under the prediction line by about 8.8 thousand, right? So if you kind of looked at the difference between both of those, you'd have about $27.4 thousand difference between the pool and no pool houses, right? So that's what they're just explaining that here. Okie doke. That's good. That's not too bad, right? But maybe you didn't know, like, okay, like I'm supposed to add these up and average them, It pretty much, when it says, use the, right here, use the residuals, right? So you just go use those residuals. And it does say something about on average, right? So it's kind of giving you some clues there. Use the residuals, take the average of each of those and compare. It gets a little tricky, maybe you don't fully get the credit for that, but I hope so. I hope so. Okay, part D. The conditions of inference have been checked and verified. Oh, sorry, I didn't read the prompt here, but they split it up, right? You have the two different models, and then the conditions are met, and they do a 95% confidence interval, but this is for the difference in the two slopes. So they're doing the slope of one compared to the slope of the other. You have to imagine on your own that the null hypothesis would be like one slope minus another slope would equal 0, right? Where there is no difference between the slopes. That would be your null. And then your alternative hypothesis would be that there is a difference and that those slopes are not the same, right? So that's kind of what we're testing, even though you don't have to write all that out, right? So is there a significant difference? Well, I can see here that it goes from a negative to a positive and 0 is captured. I just said that the idea is that the null hypothesis would be 0. So this captures 0, which means we don't really have any evidence to reject it. It looks like having a difference of 0 is possible according to the interval. So we would not reject that and don't have any evidence to say that they're different. Okay, so there's part D. Nope, no, this confidence interval does not indicate a difference, right? Because the interval includes 0. Okay, part E. We're almost done. Look at that last problem. That one wasn't bad, right? You've interpreted confidence intervals before, so you should be able to do that. Okay, use the regression model for houses with a swimming pool and the regression model for houses without a swimming pool to estimate how much greater the price for a house with a swimming pool would be than the price of the house with the same size without. How does this estimate compare with the result from part C? So in part C, we said there was no difference in the slopes, but now we're talking about the overall price, right? So there's two ways you can do that. They said use the models to estimate the difference. Sorry, there's two ways you can do it. You can actually, like, the easiest way is just looking at the y-intercepts, because those are where, like, those kind of give you an idea of the difference between the two lines, right? Whoops. So I can see how far apart these lines are, just by looking at the difference in the y-intercepts. So that looks like a difference of about 16, right? Approximately $16,000. But another way to do it would be to just pick a value like 2,000 or whatever, 2,500 for the square feet, put it into the size in the equation, and then calculate a price for both and look at the difference there. So you'll see that's what they did in part E here. They said, okay, approach one, you can just actually calculate some prices for any particular square foot that you want. Just pick something in the middle, and then you can talk about that difference, right? And then, or approach two would be take the y-intercepts and look at that difference, which comes out to like almost $16,000, and look at that difference, right? Now you are supposed to kind of compare that to parts, what we had before, where before we said it was like $27,000 difference. Sorry, not the part D, but part C, right? And then here we had about $16,000 or maybe $29,000 difference, depending. So you just have to compare whatever you came up with, kind of compare that to the, whoops, went too far. Compare that to the 27,000 and say, oh, it's about the same, a little more, a little less. It's definitely going to be a positive increase, though, right? Houses with a pool are more expensive in general. Okay, that's it. That's number 6. So it isn't too bad. Some of them, they really do, like number 6 is really throw you a curveball in there, and they can be really goofy sometimes. Um, do your best to figure them out, and don't waste tons of time doing it for sure. But if you have the extra time, you can come back to it later and maybe try to work it out. But make sure you don't just skip the number 6. That would be a huge mistake, because they almost always give you a few easy ones in the beginning that you should be able to knock out and get some points on pretty quickly, right? So don't just skip the number 6 because it's a number 6 and you're scared of it. That would be a huge mistake. All right, good luck in the future.